Oh, well, hello there. Today we're back. And today we wrap up everything we've done with derivatives. Let's see. What do we know? We know the derivative of a constant function. That's 0. Do we know the derivative of a linear function? Yep, that's the coefficient of s. Do we know the derivative of a polynomial function? Yes, that's our n x to n minus 1. How about trig? How about inverse trig? How about exponential? No. How about logarithmic functions? Haven't talked about that yet, have we? So, let's talk about logarithmic functions, but before we do that, let's talk about and review what we know about exponential functions. We know that a to the x becomes derivative a to the x ln a. We know that e to the x derivative becomes e to the x. Now, we also remember pre-calculus, don't we? And we remember the transformation. Remember the log base 2 of 8 equals 3 means 2 to the 3 equals 8? Ha. Log base a of, say, y equals log base a of x, that transforms into what? X equals a to the y. Okay, so this is derivative x. Okay, that transformation, right? If we know this, those 3 things right there, we can now get the derivatives of the log functions. So let's take a look at how this is going to work. All right, to start with, let's take log base a of x, because we're going to do log base a, and then of course we're going to do the most commonly used logarithm, which is natural log. Log base a of x. Now, here's an important lesson in calculus, and maybe an important lesson in life. Take something you don't know how to do and turn it into something you know how to do. Can we turn this into something we know how to do? That's right. We're going to put this in exponent form. So y equals log base a of x becomes x equals a to the y. 3 to the 4th equals 81 means log base 3 of 81 equals 40. I learned that because I passed pre-calculus. Oh, wait a minute. This looks familiar. What did we do with inverse trigs when we got to this step? Took the derivative with respect to x, didn't we? Right, remember, x equals sine y, right? So here we go. So find dy dx. Here we go. 1 derivative of a to the y. That's a to the y, ln a, but I'm differentiating with respect to x, and this is a y. But I know the chain rule, and I know implicit differentiation. It's kind of the same thing. dy dx. Remember doing that? Right? This looks an awful lot like those inverse trig derivatives that we did in the previous video. Now let's solve for dy dx. dy dx equals 1 over a to the y ln a. Now, this is 100% correct. But it would be nice if we could express this in terms of x, couldn't it? But is there, wait a minute. So I can just write this instead of writing x, x. And then we write it here, 1 over ln a. And this is the derivative of the log base A of x. Now, in our next video, we're going to do this chain rule style. And you're going to see how we do something in general that's a logarithmic function. But for now, let's just get it down when we just are differentiating x. So log x is 1 over x times 1 over ln a. Wow, that sounds an awful lot like the exponential, doesn't it? Yes, it does. Why is that? Because they're inverses. Okay, so here we go. Let's try log base e of x. Log base e of x. That's like when you get in trouble at home and they call you by your first name. Anthony. Who's Anthony? Oh, right. So if I say log base e of x, who's log base e of x? What's this commonly known as? Natural log? Okay. Well, do you want to go through that whole process again, right? We could, but let's skip right down to the box. So y prime is going to be 1 over x times 1 over natural log e, because that's the basic. But on my planet, what's natural log of e? That's right, 1. So when you have y equals natural log of x, the derivative is just 1 over x. And this is a very commonly used derivative. Why? Because we use natural log in many, many equations to model what goes on out there in life. So get good, get familiar with derivative of natural log. You're going to use it a whole lot. Now, derivative of natural log of x, 1 over x. Derivative of log base something of x, 1 over x, times 1 over the natural log of that something, which is a lot like the derivatives of the exponentials, isn't it? The derivative of e to the x is just e to the x. The derivative of a to the x is a to the x times natural log a. So whenever you're dealing with a base that's not e, then you have to add in that extra natural log. But this is it. This is your life. And now in our next video, we'll put all these together chain rule style, which is a whole lot cooler than Gangnam style, if you ask me.